Hello and welcome to the flipped instructional recording for the 3.13 Sound Waves Lab. We'll go over part 1 and part 2 for submitting this graded assignment. As you work through and listen to the recording, be sure you take some notes on your lab report so that you have some ideas and things that can help you get the best grade possible. And remember, you do have a notebook slide that you need to update for this lesson. So be sure to do that, add some notes and your guiding questions. So as we get started with this lab, the first thing we want to do is take a look at what we are trying to do. So sound waves have a repeating pattern with a specific wavelength, frequency, and amplitude. If you don't have those keywords defined in your notes, you need to make sure you have those added. So in this lesson, you're going to conduct an investigation to look for patterns in the characteristics of sound waves. So this is usually the answer to the first question on your lab report. So here are your lesson goals, the lab guidelines, and the notebook template if you need it. You'll be using rubber bands and household objects. So an empty tissue box, or something you could cut a hole in, maybe a shoebox or a plastic cup. Your guiding questions are: what causes sound waves? What are the parts of a wave? What do oscilloscopes do? And what affects the pitch of sound? And what is the purpose of this experiment? All right, so as we get into the lab, we know that sound is caused by vibrations, and when you pluck a string on a guitar, the string vibrates, which causes particles in the air near it to compress and bump into more particles and then spread back out. Compression and spreading out, which is called rarefaction, continues like a chain reaction. So let's take a look at the video. All right, so there you were able to kind of see a visual image of how that works and what it looks like. So sound waves can be represented by sinusoidal waves. So an oscilloscope is a machine that shows the wave shape of an electrical signal. And when connected to a microphone, they show the wave shapes of sound. So you can kind of look at the picture here. This is a great image to put into your notes. If you don't have the snipping tool on your computer, or depending on what version of Microsoft you're using, or even if you have a Mac, if you have Windows, you could do Light Shot. So that's they're both snipping, or download the snipping tool, just Google it. It lets you just, if you can see my screen, it kind of turns dark. I'm able to select this area, make a copy, and then I could paste it into my notes. So that's a really helpful tool to have. So again, when we're looking at a wave, we know the amplitude of the wave is the distance from the center line to the top of the crest. And so you want to make sure you know these parts of the wave. The wavelength is the length of one complete wave in a cycle. So like the tops would be the wavelengths, or you could do the bottom, the troughs. So make sure you know that. And the frequency is a measure of how many wavelengths pass a given point per second. So all of these words you need to have in your notes as well. So the loudness of a wave depends on the energy of the wave. So that's important to know. If you look at the image here, you can kind of see that. The harder you pluck a guitar string or strike a tuning fork, just like the harder you would hit a drumstick, the greater the vibration, which causes a greater number of air molecules to be displaced, which creates a larger amplitude and a larger sound. So you can kind of see how that works with this picture. So the rate at which a source vibrates affects the pitch. So the faster vibrations produce a high pitch with high frequency waves and with a short wavelength. So what that means, high frequency, like frequency, meaning how often something happens. So kind of let your brain think about that and set in for a minute. High frequency means there's a lot of them. So when you see an image of something with high frequency, it's got a lot of waves. That also means the pitch is high. And the wavelength is going to be short, right? This amount of space is tiny compared to a longer wavelength that's got a lower pitch and a lower frequency. That means, look, there's only one full wave in this image. So one wave, low frequency, high frequency. So slower vibrations produce low pitch, low frequency wave, and longer wavelengths. So in this experiment, you're going to observe the relationship between string length and frequency, as well as other relationships between the sound wave model and observable features of sound using a virtual tool. All right, so review the lab safety guidelines. There's not really a lot of lab safety here. This investigation is designed to be completed in 2 days. Basically, you work through the experiment and then you do your lab report. So the same format that we've had. You always want to make sure you download the document and take a look at what it's asking you to do. So we've already been able to answer the purpose of the experiment. And then we want to look for the variables that we want to identify. And then the tools that we're going to use, the procedures. So this looks very similar to what you've done before. So as we work through our, get out of that one, as we work through our experiment, we'll kind of refer back to that Word document to make sure that we understand and that we're completing everything. So the question you're seeking to answer, what's the relationship between string length and frequency? What are the patterns and the characteristics of sound waves, such as pitch and loudness? So these are the 2 things that you're trying to answer. So there's 2 parts to the experiment that you'll be doing. So you need both of those in question number 1. All right, so in part 1, it's loading. Okay, we've got a virtual experiment here that we're able to look at. So it says, select the buttons to change the length of the string plucked on the device. Observe the frequency of sound produced and the wave pattern in the oscilloscope. Notice that the way the sound and wave pattern changes after the string is plucked, and record your observations. All right, so here you can tell that, let me scroll down a little bit. If you click the button, it's going to move this device for you. So if we click it, you're able to see, observe the frequency of the sound and notice the way the sound changes. All right, so it says record the data in a data table. So if we're looking, it's going to give us a number of frequency. So in your data table, you would want to set it up where you're able to record string length, frequency. It also has you look at the way the pattern changes, and you basically record that stuff. So if you're putting that into a data table, you definitely want to have string length and frequency in your boxes. And we did that before in a Word document under Insert and Table. So you can kind of build that however you would like. Or you could draw it in if you wanted to do that as well. So if I scroll down here and do this again, the frequency of 15.5 is, I missed it. I was writing it down, 440.0 hertz. All right, so then 17.5, the string's a little longer, 400. So as I'm doing this, watch and see what kind of patterns you see. So at a 20 centimeter string, it's 350. 22.5 is 320. So you should see a pattern here. 25 is 280. And then 27.5, 250. And the last one, 30, this is the longest string, 225 is the frequency, the hertz. Okay, so we've gotten all of that information down. You should have collected all that data and you're ready to move on. Now in part 2, it's saying you're going to design an instrument to make a sound at a minimum of 3 different frequencies. So for example, you could use an empty tissue box like they have here and rubber bands to create a homemade guitar. So you would include a picture or a sketch of your design in your lab report. Don't forget that you have to add that at the end. And then you'll explain how you applied what you learned to create your instrument. My computer's taking a while today to switch over. So this gets you into the next part of the lesson, which I believe this is going into 3.14. Let's double check. Yes, so sound waves 2, 3.14. And so now it's getting into the specifics of your lab report. It says, again, sound waves have repeating patterns with a specific wavelength, frequency, and amplitude. And we conducted an investigation, and now we're going to write the lab report. So here, basically, it just gives you the lab guidelines again, and then you're directed to the Dropbox eventually. My computer's just not cooperating today. All right, so you've got your rubric, you've got the lab report again, and then you're able to upload the assignment. Yours probably looks a little different. This is the teacher screen. So if we go back to the report, we know the purpose. Remember, there were 2 things. And then we've got the variables. So remember, the independent variable is the thing that you are changing. So going through part 1 and even in part 2, you're changing one thing. And then the control variable, the dependent variable is what we're measuring. So we wrote down a number. We were measuring something in hertz every time. So what was that? That's your dependent variable. And the control variables are the things that do not change. So in our example, it would be the tissue box doesn't change, right? That would probably be the only thing. So you have that. You've got your variables identified. Now you're collecting what tools did you use. So you're going to use the virtual lab, the simulation. You also have the tissue box, rubber bands, that kind of stuff. Here you write out the procedure. So in the second part of the lab, it talked to you about how you would design and test. So this is where you type out step 1, what are your materials? Step 2, step 3, and list out your steps. Here you're going to record the observations from the first part of the experiment. So if you were going along with me and we wrote down all those numbers, 15.5 was the string length, and then the frequency was 440 hertz. So we did that for all of those string lengths. So you're going to write that down here. Remember, you could insert a table if you want. Just go to the top of your Word document, go to insert, and you can put a table in, or you can just draw something in, something like that. And then it's asking you to create a graph that shows the relationship between the string length and the frequency. So if I, let me see if I can move this up so you can see the top of my screen. Let me do enable editing so it lets me see it. So if I want to insert, remember a table is here, and then I can also insert a smart chart that's going to help me create a graph here. So you can do that, or you can print this out and draw it in. It's up to you. Okay, but you remember that your variable on the x-axis, which is the horizontal line, that's going to be your independent variable, and the y-axis going vertical up and down is going to be your dependent variable. So we're looking at the length of the string and then the frequency. So you'll have to put that on a graph, and that needs to be here in number 2. And then when we answer the conclusions, what can you draw about the relationship between the string length and the frequency and the other patterns that we saw, such as pitch and loudness? So be sure to answer this part as well. So you would state an evidence-based claim means that you pull in your data. So here you would say the shorter the string, the higher the frequency, or the longer the string. My evidence shows the longer the string, the longest portion tested had the shortest frequency. You're going to use your evidence that you got from your data to write out your conclusion. But you also need to go in and add some details. What does that do to the pitch and the loudness? Maybe you have to go back into the lesson and read that again so that you can see if something has a higher frequency, is it louder? Or you may have to look that up. But it talked about it in that first part of the little lesson that we talked about. And then finally, for number 2, it says, how did you design an instrument that could play 3 different frequencies using your household items? So you could, what I would do is just click here, and if you hit enter several times, it'll take you to give you another page in your report. And then you can draw it in, you can upload an image and copy paste it in, something like that. But you'll need to explain, so not only do you have your image, but you're explaining how you applied what you learned in your design. So this means basically what kind of strings, rubber bands, what did you use? What did the 3 strings sound like? You're just kind of explaining that. So that will be the last thing that you'll include. Then you just save it and upload it. So from there, if you have questions on the lab, please let me know. I am in Help Lab. You can check out a link there and we can connect, or just send me a message. So I hope you enjoyed this lab, and I look forward to seeing you next time.